Hi, everyone. Welcome back to another stream. Today we'll learn data handling. So let's just see what's on the agenda. What exactly, when we say data handling, what cases we get? Basically, file input output. This is one major topic we'll be covering, and error handling. So these two are the major topics for today. If we get time, we'll cover other topics also, right? So why we're starting with this, I'll just tell you. Imagine you are in a class, right? Let me just go to my iPad and explain. Ignore the chat. I was just setting it up, so it might have some rubbish right now, but yeah. So imagine if you are in a class, right? Suppose you're in a class and there's a teacher who is teaching on the blackboard. He's teaching some stuff. You're just a student, right? You're sitting here, you have a page open, and you're taking the notes. So imagine this is a script, right? I'm running it. So this is running. You're taking notes. So this data is there in the script. So after the run ends, after I stop the script, after the teacher leaves the class, right? Imagine it like that. You obviously don't want to tear up your note and throw it away. You want the notes to be saved. You want the notebook to be saved, right? So what we do is we take the notebook and save it in a file, right? And when the next class starts, like I start running it again, right? I run it again. There is the file, there is the notebook you have. You are sitting in the class, and the teacher says, "Okay, tell me what all I have taught till yesterday." So you obviously don't want to key like oh, I don't know, but you have the notebook, right? You open that notebook's page and you start writing from there. You read these parts that yes, teacher, you have taught these parts, and you start writing from there, right? This is how it works. So in Python also, we have these things uh, that we can save data into files, we can read it back. So this is the most important part of file input output. Okay, let me just open my code so that you can see the file input output things. Mm, Just give me a moment. So what happens is when the program is active, it accesses the data that's stored in the RAM, which is the random access memory. RAM is really fast, but it is expensive and it requires a constant power supply. If power supply is out or if the program stops, then it cannot access the memory from the RAM. All the memory is lost. So we save it in a file and we store it in a disk drive. Okay. So today we are just using a plain simple file of which is in Python terms also called a flat file. A flat file. So these flat files are just sequence of bytes stored under a file name. We can read the file into memory and write from memory to a file. And we before reading or writing a file, we need to open it. So let's start with day five. Let's have here day five. Also, the projects. So last time I told how to move to index-based code. I have uploaded it on GitHub. You can check it out. That how we can take the name-based to-do list and move it to an index-based to-do list. For that, what we have to change? We have to change the data structure. Since dictionaries are non-indexed, we have to go to an index data structure. So we go to a list of dictionaries, right? So since the lists are indexed, so we can access the items in the list using a index. Good. So let's just go to I think day four was the project. So I'll just say We name this to day 5. Day 5. I'll increase the font size, don't worry. Font, check this one. Hopefully that's okay. Hopefully it's clearly visible. Yep, I think it's clearly visible. So if you are here, guys, just draw, drop a like, drop a question in the chat because now I have my extra monitor. Now the chat is properly set up so I can answer all your queries. So we'll just start with a new Python file and name it file. It's a Jupyter. Let's start a Jupyter notebook. New Jupyter notebook. Name it day file, file IO, file IO. Right. Uh, so as I said, let's just have a file also. Okay. Let's have a file. Uh, let's open Word. Or let's just create a file here, right? New file. Um, a file dot txt, and we write suppose this is the file. This is Python file. File. Okay. So we will save this. We'll close this. The first thing we have to do is we have to open the file. So what do you mean by opening the file? Before it can be read, the file has to be opened. So what we do, we write, we take a variable and assign it to the opened file. So let's say uh, f, f is the variable, which is the standard way is open day5, day5.txt, comma r. So what is r? R means as readable file. So there is R, there is RB, readable as buffer. There is W, which is write. There is WB, which is write as buffer. So these are all the types of file openings. So the basic structure here is opening a file. Let's say file IO, file IO. And let's add up another markdown here. Opening a file. So the format here, let me just write here. The format would be file object, which is the variable that is the file, and we say open, which is the Python function, and then file name and the mode. So how in which mode the file has to be opened? So in mode we can say R is read, W is write, X is write only if file does not previously exist. Only if file doesn't previously exist. Why is write giving error? And A is append, which is write to the end of file. That is write to the end of a file. So let me just keep it in quotes. And so this is about mode letter 1. So mode can be of two letters also. So when I said RP or WB, so mode letter 2. What mode letter 2 is, let me just, what mode letter 2 can be is either T, it can be a T or a P. So T means as text, open file as text, and B means as binary. So this is basic flat files, right? So after opening the file, you can call the functions and everything to. Okay, okay. Just give me a second. Let it. Yeah, sorry. So this is how it works, right? Mm, this is how it works. Okay. Let me just do this. Mm, should be day5.txt. So now my file is open, right? Now my file object is open. So now it's open, right? So we say that a different variable like content equal to f dot read. Okay, and then enter. We see what the content is. See, this is the content. This was the content, right? This was the content. And then we close the file object. We always have to close the file object. So f dot close. Yes, the file object has to be closed, right? Now this is reading from a file. Reading from file. How to write into the file? Let's see how to write into a file. Right. File. So similarly, we have to open that file, right? We have to have some content. So content equal to suppose Python day 5 is fun, right? Now what we do is we have to write it. So file object equal to open. Suppose I say day 5 underscore 2, and we do it as write. How? Text. We write it as text. And then we close the file object, f dot close. But first we have to write it. So f dot write content. For writing, we just have to write as a text because it's open as a writable file. It's the object is open as a writable file. Now I have to write the content in it. So the content has been written, and then we close. But since you see there is no day 5 file already, so it will not work like this. We have to have a day 5 file. So let's just have it as day 5 for now, and f dot close. We'll just run it again because there is no. See, now if we go into day 5, see Python day 5 is fun. It has overwritten the file because this was our content. So if we say Python day fun is very fun. See, it has overwritten the content. Now, if you read it again, see Python day 5 is very fun. Now, I just want to append to it, right? I don't want to change this Python day 5 is very fun. I just want to add to it because every time the notebook is opened, I don't want to erase the previous node. I just want to add to the previous node. So let's just say appending to a file, and we say that new content is hello viewers, welcome to Python data. Now how we add it? We say first thing we open it as day5txt dot at. Append as text. See, we had modes. A is append right to the end of a file as text. At. Now we say f dot write new content and then close. F dot close. Let's see what happened. Hello viewers, welcome to Python day 5. Now what happens is, since there is no, we have not used any special characters, so it is written like this. Let's see if we can write it like this after the special character. See, it gets to a new line. So it's just appended to a new line because already we had the first content. So let's just write this and then check it again. Hello viewers, welcome to Python day 5. If we say another n here and then run it, so it will add. See, after two lines, it has added another welcome to Python day 5, right? Now what we can see is, suppose we have a very large file. We will not always have this kind of files, right? So we have a very large file. Let me just take this example from here. Suppose we have a poem, right? We have a large file. Suppose we have a very large file. Let me just and Let me take here. We have a very large file. So what do we do in large file cases? We use chunking. What is chunking? Breaking the file into small pieces so that uh, it can be read or used properly by the what you say by Python. So we have to break it into small pieces, right? So we say this is a poem, and now we chunk it. So first thing we do is open the file. So we are going to write it in a new file. Let's say f equal to open file. Let's say the name of the file is poem.txt, poem.txt, and we open it as x file. Let's go. Okay, fine. Access. Okay, I've already it has been created already. SWT. Okay, let us open it as WT. Now we say that the size is the length of the point, length of point. And then we say what's the size of the point? That's point notation. So size is 150. So let's say we take 50-50 chunks. So offset where it starts, offset initial is 0, chunk is 50 characters, 50 characters. Now we run a while loop. So while true, if when should it break? Offset plus chunk is greater than size, or offset is greater than size because offset will be increased every time, right? Then break. What else? Now, what happens if offset is not present? So we just do f dot write poem offset till offset plus chunk. So suppose, and then we update the offset. So offset plus equal to chunk. So let's just see. We can add for debugging. We can add print poem offset dot chunk. Let's add a string. Offset is offset, comma chunk is chunk. Poem poem written is right. Let's run it. Let's see. Offset is 0, chunk is 50, poem written is there was a young lady named Bright. Okay, these are 50 characters. Whose speed W? So this is 50 characters. Up to this is 50 characters. Now offset is 50 now, so it starts from 50. It starts from 50. Chunk is also 50, so it goes from 50 to 99. I mean 50 to 100, but in Python the last is not inclusive. So poem written is whose speed W was far faster than light. She started one day in A. So offset is now 100, chunk is now 50, and the poem written is relative way and returned on the previous night. Now offset is 150, chunk is 50. So offset is now greater. Uh, so no poem is written, so it's blank, and then offset gets 200, which is greater than size, right? So why can't we use offset greater equal to size? Because the last one is not inclusive. So just in case there is one character remaining. So if I just add here previous night and two full stops and then do this. So see the two full stops will be added. That's why we cannot use size. And now we close the file. Obviously f dot close. So take some time to reflect here. Let's just wait and see how the poem.txt comes. Take some time to reflect on the Python window. Or let's just read it, right? Let's just read it. F dot open dot txt as a read. Right? So equal to txt as a text F dot is F dot read. And then we say now which next F dot close content. Yeah. Now a very interesting thing you can see the enters or the new lines are like this, right? So this is not obviously what we wanted. We wanted them to be printed in new lines. So what we can do is we have another method called read line, right? Read line. What read line does, let's show you. So similar things, I'll just copy it from here, paste it here, enter content equal to. So if instead of using a while loop or anything, we can just use f dot read line. So lines, and then we can print content. See, it has read all the lines. Now, how we can see content is a list of lines. So for line in content, let's say uh, poem poem read equal to plus equal to line, and poem read initially. Let's just initialize poem read. Poem read is line. So poem read plus equal to line, and then we do this. We poem read, then not open it. Something happen. You can just do it like this. Print line, this, and we can use the end as this because already the end with the new line has been added. We need to open the file again. We have to read line, and then we can see there was a young lady named Bright who's. So what happened here is we opened the file, right? We used read lines. So when you print content, if you print content, you will see that read lines is a list. It returns a list of the lines and the separators, right? The lines and the separators. So when we print each line, right? We print each line and then we print this part. We print each line like this. So this is printed. So when you print this, when you print this, when you print this, let's just, oh, So see, there is an extra line because of this. So it has already gone to the new line. So if we use print, the new line, the print also adds a new line. But if we have this end parameter, which defines that what end should be there. So if we use end equal to this, no new line, because the new line is taken from here, not from the end parameter of the print. So by default, the print ends with a new line. So when you print something, when you print something else, it goes to a new line by default. So we don't want that. That's why we have to add this end parameter. There are also other parameters like set. So that's it for reading and writing. Let's close the file now. F dot close. So you see one thing, right? When we write or when we read, we have always have to remember to close. But there is a better way to read and write. So when we use when we don't use c poem.txt is now here. You can just read it. Yeah. So when we don't close it, it might not save. So it's like you have this notebook, you wrote on it, and you kept it open, and you went away. So when you keep it open and go away, then someone else might come and tear it up. So if you have to keep it in your backpack, right? You have to keep it in your backpack and save it. So close is very important. But every time when it's a large file, you have worked on much long time. It might be that it has slipped your mind that yeah, I need to close it. So what we do is we use with open. Suppose file .txt wts f2 f2 dot write f2 and close f2 dot write. This is a new file using with keyword and just write this. We write this only. See now when we say with open file.txt we do as f2 content table f2 read content. We've read it. So content. See, when we do this, we open it we as the object. We do f2 equal to open as the object. And when the loop is exited, or when the conditional with is a conditional, right? When the conditional is exited, the file is closed by default. So the file object is closed by default. So similarly, when we are read it as f2, right? So we do content f2 dot read, and then it's opened as a read file. So we just can read it. And then it's saved to a variable called content. The file is closed and it's saved to a variable called content. So now this is a new file using with keyword. So if we again open file.txt, and this is a new line in the new file, and we just add n like this. And when we do this again, so we do content f dot readlines, and then we say for line in content print line except. Oh, okay. So we have opened it as a new file. If we just say 80, so it gets appended, not overwritten. So let's just say like this. See, this is a new file using with keyword, and this is a new line in the new file. Okay, understood. So let's just take it in. Let's just take a quick 5 or 10 minute break, and then we come back again to it.